Hello students, welcome to this lecture, One Straight Lines Theory. Okay, so this class is first class for straight lines. Okay, so in this lecture, we will discuss NCERT section 9.1, 9.2 and 9.2.1. So we will cover in today's lecture first 9.1 introduction. Then we will discuss about one important remark, and then we will discuss 9.2 slope of a line, and lastly we will discuss 9.2.1 slope of a line when coordinates of any 2 points on the line are given. So lastly we will discuss slope of a line where when coordinates of any 2 points on the line are given. So make sure you have your notebooks and pens ready. So in our earlier classes, we are familiar with two-dimensional coordinate geometry. So in our previous class, we have already studied about two-dimensional coordinate geometry. So mainly this chapter is a combination of algebra and geometry. So in straight lines chapter, we will use algebra together with geometry. So mainly it is a combination of algebra and geometry. So now let us see history of straight lines. Okay, so a systematic study of geometry by the use of algebra was first carried out by celebrated French philosopher and mathematician René Descartes. So René Descartes, he was first mathematician and French philosopher who carried a systematic study of geometry by the use of algebra in his book La Geometrie, published in 1637. So now we recall of geometry, coordinate geometry. Okay, so let us have a brief recall of coordinate geometry done in earlier classes. So first of all, we will recall basics of some coordinate geometry that we have done in previous classes. So the location of the points. So we have a point, suppose 6 comma minus 4 and 3 comma 0. So how can we locate the points 6 comma minus 4 and 3 comma 0 in the xy plane? That is also called Cartesian plane. Okay, so how can we locate a point in the xy plane? So here you can see the location of the points 6 comma minus 4 and 3 comma 0 in the xy plane is shown in the figure 9.1. So let us take a look at figure 9.1 and see the location of the points 6 comma minus 4 and 3 comma 0 in the xy plane. So here in this figure you can see this axis is called x-axis and this axis is called y-axis. Basically this axis is called negative y-axis. Okay, and if we have a point a comma b, then first number a is called x coordinate of that point and the second number is called y coordinate of that point. Okay, so here you can see 6 comma minus 4. So here x coordinate is basically 6 and y coordinate is minus 4. Okay, And here, let us see this point. So here you can see the x coordinate of this point is 3 and y coordinate of this point is 0. Okay. So now basically we are going to locate the points 6 comma minus 4 and 3 comma 0 in the xy plane that is shown in the figure 9.1. So the point 6 comma minus 4 is at 6 unit distance from the y axis measured along the positive x axis. Okay. So 6 comma minus 4, this point is at 6 units from the y axis. This axis is y axis. Okay. And this axis is x axis. So 6 comma minus 4, this point is located at 6 units distance from the y axis measured along the positive x axis. Okay. And at 4 units from the x axis. So here you can see this distance is 4 units. Okay. So 6 comma minus 4, this point is at 4 units distance from the x axis measured along negative y axis. Okay. So 6 comma minus 4, this point is at 4 units distance from the x axis measured along the negative y axis. Similarly, the point 3 comma 0. So 3 comma 0, this point is at 3 units distance from the y axis. Okay, here you can see 3 comma 0, this point is at 3 units distance from y axis and measured along x axis, positive x axis, and has 0 distance from the x axis. So this point 3 comma 0, this point is basically located on positive x axis. Okay, so in positive x axis 3 comma 0, this point has 0 distance from the x axis. Clear? So I think it is clear to all of you. So we also studied there following important formula. So here we will recall some important formula that we have already studied in our earlier classes. Okay. So first formula is distance formula. So first we will recall distance formula. So here, first of all, let us take a look at this figure. Okay. So here in this figure, we have given here 2 points, P x1 comma y1 point and Q x2 comma y2 point. Okay. And we have to find distance between P and Q points. Okay. So we have to find distance between P and Q. So what is the formula to find distance between 2 points in 2D? So we studied in our earlier classes about the distance between 2 points in 2D. So the distance between the 2 points P x1 comma y1. The coordinates of P are x1 comma y1 and the coordinates of Q are x2 comma y2. And then the distance between the points P and Q is PQ. This is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. Okay. So let us see this. Here the distance between P and Q, this is basically equal to square root of x2. That is basically the x coordinate of Q. Okay. So x coordinate of Q is x2 and x coordinate of P is x1. So here we take x2 minus x1 whole square and then plus y2 minus y1 whole square. Okay. And then we take square root and we obtain distance between the points P x1 comma y1 and Q x2 comma y2 that is shown in the above figure. Okay, so you should keep in your mind this formula, distance formula between 2 points p of x1 comma y1 and q of x2 comma y2. Okay, and note this formula, distance between p and q, this is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. Then we will explore an example, one distance formula, so that the concept one distance formula will clear you. Okay, so here in this example we have to find the distance between the points 6 comma minus 4 and 3 comma 0. Okay, so basically we have given here 2 points. They are basically 6 comma minus 4 and 3 comma 0. Okay, and we have to find the distance between the points 6 comma minus 4 and 3 comma 0. So students, first of all, try it yourself and then see solution. So let us see solution, how to find the distance between the points 6 comma minus 4 and 3 comma 0. So given points are basically 6 comma minus 4 and 3 comma 0. So given points are 6 comma minus 4 and 3 comma 0. And it is known that distance between the points p of x1 comma y1 and q of x2 comma y2 is pq equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. Okay, so we studied this formula in our previous slide. Okay, so here the distance between the points p of x1 comma y1 and q of x2 comma y2, this is equal to basically pq. Okay, and pq, this is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square. So therefore the distance, this is equal to square root of 3 minus 6 whole square plus 0 plus 4 whole square. Okay, so here we put the values of x1 comma y1, that is 6 comma minus 4, and x2 comma y2, that is 3 comma 0. Okay, and by substituting the value of x1 comma y1 equal to 6 comma minus 4 and x2 comma y2 equal to 3 comma 0, we obtain distance between p and q is basically square root of 3 minus 6 whole square plus 0 plus 4 whole square. And after simplifying, we obtain this is equal to square root of 9 plus 16, and this is equal to basically square root of 25, and that is equal to 5 units. Okay, so the distance between the points 6 comma minus 4 and 3 comma 0 is 5 units. So therefore distance between the points, this is equal to 5 units. So I hope it is clear to all of you. So now let us move to next concept. So here we now study about internal section formula. So what actually said internal section formula? So the internal section formula is used to find the coordinates of a point P of x comma y that divides a line segment joining 2 points x a x1 comma y1 and b x2 comma y2 internally in the ratio m is to n. Okay, that is mean here we have given here line segment joining 2 points a x1 comma y1 and b x2 comma y2. Okay, and then we have a point p x comma y, and this point p x comma y divides this line segment AB internally in the ratio m is to n. Okay, so P point divides a line segment AB that basically made by joining 2 points a x1 comma y1 and b x2 comma y2. Okay, and p, this points divides this line segment in the ratio m is to n internally. Okay, so see this figure. So the formula is basically p of x comma y. Okay, that is equal to mx2 plus nx1 divided by m plus n comma my2 plus ny1 divided by m plus n. Okay, that means here the coordinates of p are mx2 plus nx1 divided by m plus n comma my2 plus ny1 divided by m plus n. Okay, so here the point px comma y divides the line segment AB internally in the ratio m is to n. Then the formula for the point p of x comma y, this is equal to mx2 plus nx1 divided by m plus n comma my2 plus ny1 divided by m plus n. Okay, so now the points to remember. So now we will discuss key idea. So the point P lies between the points A and B on the line segment. So the point P always lies between the points A and B on the line segment when P divides the line segment internally in the ratio m is to n. The ratio m is to n implies that P is m units from A and n units from B, okay, along the segment. So here you can see this figure. So m is to n means the distance between A and P is m units, and the distance between P and B, okay, P and B, these 2 points is basically n units. So now we discuss an example, one internal section formula. Okay, so in this example, we have to find the coordinates of the point P that divides the line segment joining A of 1 comma minus 3 and B of minus 3 comma 9 internally in the ratio 1 is to 3. Okay, so we have given this example and we have to find the coordinates of the point P. And what about the point P? So here the point P divides the line segment joining A 1 comma minus 3 and B minus 3 comma 9 internally in the ratio 1 is to 3. Okay, so students, first of all, try it yourself and then see solution. So let us see solution. So here the coordinates of A point, that is x1 comma y1, this is equal to 1 comma minus 3. Okay, and the coordinates of the point B x2 comma y2, this is equal to minus 3 comma 9, and here we have given the ratio is 1 is to 3. Okay, that means m equal to 1 here and n equal to 3. Okay, so now using the internal section formula, so we studied in our previous slide about internal section formula. So now we are going to use the internal section formula. So see this figure first. So in this figure here you can see the point P divides the line segment joining A and B internally in the ratio m is to n. Okay, and here you can see x1 comma y1, that means the point A x1 comma y1 is 1 comma minus 3, and the point B x comma y2, this is equal to minus 3 comma 9. Okay, and here m equal to 1 and n equal to 3. So the formula for the point P is basically equal to mx2 plus nx1 divided by m plus n comma my2 plus ny1 divided by m plus n. Okay, so it is known that the formula for the point P that divides the line segment joining A 1 comma minus 3 and B minus 3 comma 9 internally in the ratio 1:3 is what? So the x coordinate will be m times x2 plus n times x1 divided by m plus n. Okay, that means the x coordinate of point P is equal to mx2 plus nx1 divided by m plus n. Okay, so now substituting the values of x1, x2, m and n, then we obtain x equal to 1 times minus 3 plus 3 times 1 divided by 1 plus 3. Okay, and if we simplify it, then you will get x equal to 0. Okay, and then y, the y coordinate of the point P is m times y2 plus n times y1 divided by m plus n. Okay, so y coordinate of the point P is m times y2 plus n times y1 divided by m plus n. So now substituting the value of m, n and x1, m, n and y1 and y2, then what you will get? So then you will get the value of y. This is equal to 1 times 9 plus 3 times minus 3 divided by 1 plus 3. Okay, so if we simplify it, then you will get 9 minus 9 divided by 4. This is equal to also 0. So therefore the coordinates of point P are 0, 0. Okay, so the coordinates of the point P are 0, 0, and this is the final answer. So I hope it is clear to all of you. So now let us discuss another concept, that is external section formula. So the external section formula is used to find the coordinates of a point P x comma y that divides a line segment joining 2 points A x1 comma y1 and B x2 comma y2 externally in the ratio m is to n. Okay, so see this figure. So here in this figure you can see the line segment joining A x1 comma y1 and B x2 comma y2. Here the point P x comma y divides the line segment AB externally in the ratio m is to n. Okay, so here you can see this figure. So this is AB is line segment joining the point A and B. Okay, and here the line segment extended up to P. Okay, P point. So the point P x comma y divides the line segment joining A and B externally in the ratio m is to n. So now the formula for the point P x comma y is what? So the formula for the point P x comma y is equal to mx2 minus n x1 divided by m minus n, comma my2 minus n y1 divided by m minus n. Okay, so the formula for the point Px comma y, when the point Px comma y divides a line segment joining 2 points A x1 comma y1 and B x2 comma y2 externally in the ratio m is to n, then the formula is P of x comma y. This is equal to mx2 minus n x1 divided by m minus n, comma m times y2 minus n times y1 divided by m minus 1. Okay, so you should keep in your mind this formula. So when a line segment is divided by a point externally in the ratio m is to n, that case the formula is this. Okay, so this formula is for external section. And now key idea, the point P lies on the line extended beyond the line segment AB. Okay, so point P basically lies on the line extended beyond the line segment AB. So here the point P doesn't lie on the doesn't lie between A and B. Okay, so the point P lies on the line extended beyond the line segment AB here. The ratio m is to n implies that P units from A and n units from B. Okay, that means this distance A to P is m units. Okay, and B to P is n units. Okay, so the ratio m is to n. This implies that P is m units from A and n units from B. Clear? So let us take an example related to external section formula. Okay, so see this example. So in this example, we have to find the coordinates of the point P that divides the line segment A 2, 3 and B 7, 8 externally in the ratio 3:2. Okay, so now we have to find the point. We have to find the coordinates of the point P that basically divides the line segment joining A. That the coordinates of A is 2, 3 and the coordinates of B are 7, 8. Okay, so the line segment joining A 2, 3 and B 7, 8. Okay, so P divides the line segment joining A and B externally in the ratio 3:2. Okay, so students, first of all, try it yourself. So you have to find the coordinates of the point P. So try it yourself. So let us see solution. So here the coordinates of A are 2, 3. Okay, so that means the point A x1, y1 is 2, 3 and the point B x2, y2 equal to 7, 8. Okay, given to us this, and m is equal to 3 and n equal to 2. Okay, so given to us A of x1, y1 is 2, 3 and B of x2, y2 is 7, 8. Okay, and m equal to 3 and n equal to 2. So using the external section formula, so we know about external section formula. So now using the external section formula, so first of all, see this figure. So here you can see the point P x, y that divides the line segment AB externally in the ratio m is to n, where A of x1, y1 is 2, 3 and B of x2, y2 is 7, 8 and m is 3 and n is 2. So the formula is P of x, y. This is equal to m times x2 minus n times x1 divided by m minus n, comma m times y2 minus n times y1 divided by m minus 1. Okay, so the formula for the point P x, y, this is equal to m x2 minus n x1 divided by m minus n, comma m y2 minus n y1 divided by m minus n. Okay, so now we have to substitute the value of A x1, y1 and B x2, y2 and m equal to 3 and n equal to 2. Okay, then we will get the point P x, y. So here you can you first solve for the coordinate x coordinate. Okay, that is x equal to m times x2 minus n times x1 divided by m minus n. Okay, so now substituting the value of x1, x2 and m and n, then you will get the x coordinate for the point P is 3 into 7 minus 2 into 2 divided by 3 minus 2. Okay, so now after calculating, you will get this is equal to 17. So x is equal to basically 17. And the y coordinate for the point P, that is y equal to m times y2 minus n times y1 divided by m minus n. Okay, so after substituting the value of y1, y2 and m and n, then you will get y this is equal to 3 times 8 minus 2 times 3 divided by 3 minus 2. Okay. And after calculation, you will get the value of y. This is equal to 18. Clear? So x is equal to 17 and y is equal to 18. So now you can easily find the coordinates of the point P. So therefore the coordinates of the point P are 17, 18. Okay. So the coordinates of the point P are 17, 18. So it is the final answer. So I hope it is clear to all of you. So now let us discuss about midpoint. So what is midpoint? So let us see first figure. Okay. So see this figure. So in this figure here you can see the line segment joining the points a x1 comma y1 and b x2 comma y2. Okay. Here the point px comma y divides the line segment a and b internally in the ratio 1:1. Okay. So in particular, if m equal to n, okay, if m equal to n, then the coordinates of the midpoint of the line segment joining the points x1 comma y1 and x2 comma y2 are x1 plus x2 by 2 minus y1 plus y2 whole divided by 2. Okay. So in particular, if the point P x comma y divides the line segment joining the point A x1 comma y1 and B x2 comma y2 internally in the ratio 1:1, then we get the point P x comma y, that is basically called midpoint of the line segment joining the points x1 comma y1 and x2 comma y2. Okay. So this is the formula for the midpoint of a line segment joining the points x1 comma y1 and x2 comma y2. Okay. So now let us take an example related to midpoint. So this example is very simple example. Okay. So first of all, try it yourself. So see, here we have to find the midpoint of the 2 points A 4,7 and B 10,15. Okay. So we have to find midpoint of the 2 points A 4,7 and B 10,15. Okay. So first of all, try it yourself, student, and then see solution. So let us see solution. So since m equal to n, the ratio is 1:1. Okay, that means the point P x comma y that divides the line segment joining A 4,7 and B 10,15 internally in the ratio 1:1. Okay, so since m is equal to n, so the ratio is 1:1. So the midpoint P of x comma y is given by using this formula x1 plus x2 by 2 comma y1 plus y2 divided by 2. Okay, so this is the formula for midpoint of 2 point x1 comma y1 and x2 comma y2. Okay, so now here are the x coordinate of the point P, that is x equal to 4 plus 10 by 2. This is equal to 14 by 2 equal to 7. Okay, and y equal to 7 plus 15 divided by 2. This is equal to 22 divided by 2. Okay, and this is equal to 11. So x equal to 7 and y equal to 11. So therefore the midpoint P of x comma y, this is equal to 7 comma 11. So that means the midpoint of the 2 points A 4,7 and B 10,15 is 7, 11. Clear? So I think it is clear to all of you. So now let us move to another concept. So now we will discuss about area of the triangle. So you have studied in your earlier class about area of the triangle. Okay. So now by using formula, how can we find the area of the triangle? So suppose we have given a triangle ABC. Okay. So the vertices of the triangle ABC are x1 comma y1. Okay. And x2 comma y2 and x3 comma y3. So the triangle ABC, the vertices are A x1 comma y1, B x2 comma y2, and C x3 comma y3. So then how can we find area of this triangle? So area of the triangle whose vertices are x1 comma y1, x2 comma y2 and x3 comma y3 is basically equal to 1 by 2 modulus of x1 times y2 minus y3 plus x2 times y3 minus y1 plus x3 times y1 minus y2. Okay. So remember this formula. So by using this formula, you can easily find area of the triangle whose vertices are x1 comma y1, x2 comma y2 and x3 comma y3. Okay. So basically we obtain this formula from determinants of x1 y1 1, x2 y2 1 and x3 y3 1. Okay. So if we calculate the determinant of x1 y1 1, x2 y2 1 and x3 y3 1, then you will get this formula for the area of the triangle, okay, whose vertices are x1 comma y1, x2 comma y2 and x3 comma y3. So students, you should remember this formula. So by using this formula, we can easily find the area of the triangle whose vertices are given. Okay. So note this formula. So now let us take an example related to area of the triangle. So in this example, we have to find the area of the triangle whose vertices are given to us 4, 4, 3, minus 2 and minus 3, 16. Okay. So we have given here triangle whose vertices are given. So we have to find the area of this triangle. So students, first of all, try it yourself and then see the solution. So let us see solution. So area of the triangle whose vertices are x1 comma y1, x2 comma y2 and x3 comma y3 is 1 by 2 modulus of x1 times y2 minus y3 plus x2 times y3 minus y1 plus x3 times y1 minus y2. Okay. So note this formula. We will use this formula in after our in the class. Okay. So basically this formula is very important formula for finding area of the triangle whose vertices are given. Okay. So area of the triangle whose vertices are x1 comma y1, x2 comma y2 and x3 comma y3 is basically 1 by 2 modulus of x1 times y2 minus y3 plus x2 times y3 minus y1 plus x3 times y1 minus y2. Okay. So note this formula. So first of all, let x1 comma y1 equal to 4 comma 4. Okay. And x2 comma y2 is equal to 3 comma minus 2 and x3 comma y3 is equal to minus 3 comma 16. Okay. So first of all, we let the vertices of the triangle x1 comma y1 4 comma 4, x2 comma y2 3 comma minus 2 and x3 comma y3 is equal to minus 3 comma 16. Okay. So now hence the area of triangle is what? So if we substituting the value of x1 y1, x2 y2 and x3 y3, then you will get area of the triangle. Okay. Hence the area of triangle is basically 1 by 2 times modulus of 4 times minus 2 minus 16 plus 3 times 16 minus 4 plus minus 3 times 4 plus 2. Okay. So this is the area of the triangle whose vertices are 4 comma 4 comma 3 comma minus 2 and minus 3 comma 16. Okay. So now let us simplify this. So if we simplify this, then we will obtain this is equal to minus of 54 modulus of minus 54 divided by 2. Okay. And as you know, minus a modulus of minus 54 is 54. Okay. And 54 by 2 is 27. So therefore, area of triangle is 27. So you may ask why we take here modulus sign. So because because area of triangle is always positive. Okay. So for getting positive value of area of triangle, we used here modulus sign. Okay. So always remember here we use modulus sign. Okay. Because area of triangle never negative. Okay. Area of triangle is always positive. That's why we use here modulus function. Okay. And then we get the area of the triangle whose vertices are 4, 4, 3, minus 2 and minus 3, 16. This is equal to 27. Okay. And this is the final answer for this example. So now we will discuss remark. Okay. So if the area of triangle ABC is 0, then what we can say? So if the area of triangle ABC is 0, then 3 points A, B and C lie on a line. Okay, that is they are collinear. Okay, that means they 3 points lie on same line. Okay, so if the area of triangle ABC is 0, then 3 points A, B and C lie on a line. Okay, and that means A, B and C points are collinear. So let us take an example. So in this example, we have to show that 3 points A 1, 2, B 3, 6 and C 5, 10 are collinear. Okay, so we have to show these 3 points are collinear. So how can you show these 3 points are collinear? So students, try it. So let us see solution. So we need to show that given points are collinear. So for this, we find the area of triangle ABC using the formula. So area of the triangle whose vertices are x1, y1, x2, y2 and x3, y3 is what? So the area of the triangle whose vertices are x1, y1, x2, y2 and x3, y3 is equal to basically 1 by 2 modulus of x1 times y2 minus y3 plus x2 times y3 minus y1 plus x3 times y1 minus y2. Okay. So use this formula for finding the area of triangle ABC. So let here x1, y1 is 1, 2, x2, y2 is 3, 6 and x3, y3 is 5, 10. Okay. So first of all, we let here x1, y1 is 1, 2, x2, y2 is 3, 6 and x3, y3 is 5, 10. So putting this value into the formula of area of triangle. Okay, then we know this formula, area of the triangle whose vertices are x1, y1, x2, y2 and x3, y3 is 1 by 2 modulus of x1 times y2 minus y3 plus x2 times y3 minus y1 plus x3 times y1 minus y2. Okay, so now put the value of x1, y1 that is 1, 2 and x2, y2 that is 3, 6 and x3, y3 that is 5, 10. Okay, so put these values into the formula below. So area of the triangle ABC, this is equal to 1 by 2 times modulus of 1 times 6 minus 10 plus 3 times 10 minus 2 plus 5 times 2 minus 6. Okay, so this is the area of triangle ABC. So now now simplify this. So this is equal to 1 by 2 modulus of 1 times minus 4 plus 3 times 8 plus 5 times minus 4. Okay, and then you will get this is equal to basically 1 by 2 modulus of minus 4 plus 24 minus 20. Okay, and if we here cancel, then you will get this is equal to 0 by 2. Okay, and this is equal to basically 0. Okay, so here we get area of triangle ABC is 0. So since the area of triangle ABC is 0, and we have seen in remark that if area of triangle ABC is 0, then the 3 points A, B, and C are collinear. Okay, so since the area of triangle ABC is 0 here, so therefore the points A 1, 2, B 3, 6, and C 5, 10 are collinear. Okay, that means the points A 1, 2 and B 3, 6 and C 5, 10 lies on a line. Okay, clear? I think it is clear to all of you. So now we will discuss slope of a line. Okay, so before going to discuss slope of a line, first we recall about supplementary angle. So what is supplementary angle, students? So a line in a coordinate plane forms two angles with the x-axis. Okay, so suppose we have a line in a coordinate plane, and a line in a coordinate plane forms basically two angles with the x-axis. Okay, and these two angles are called supplementary angle. So for example, if a line makes an angle theta with the positive direction of the x-axis. Okay, so let us see this figure. So if you see this figure, then it will clear to you. Okay, so if a line, here you can see the line L makes an angle theta with the positive direction of the x-axis. Okay, here you can see in the figure 9.2. Okay, so the other angle at the intersection will be 180 degree minus theta. Okay, so other angle that the a line makes another angle 180 degree minus theta with the positive direction of the x-axis. Okay, so 180 degree minus theta and theta. These two angles are called supplementary angle basically. So both of these angles together always sum to 180 degree. Okay, so keep in your mind this point. So if we have two angles, okay, and if these two angles are supplementary angle, then if we take sum of these two angles, then we obtain always 180 degree. Okay, so here you can see in this figure, we have here two angles, okay, with the x-axis, theta and 180 degree minus theta. Okay, theta and 180 degree minus theta. So if we take sum of theta and 180 degree minus theta, then you will get 180 degree. Okay. So both these angles, theta and 180 degree minus theta, together always sum to 180 degree. So which is the definition of the supplementary angles. Okay, so you should keep in your mind this point. So if we have two angles, and if these two angles are supplementary angle, then sum of these two supplementary angles always 180 degree. Okay, so keep in your mind this point. So now we will discuss about inclination of a line. So what is inclination of the line? So okay, so the angle, say theta, made by the line L with positive direction of the x-axis. Okay, and measured anti-clockwise. Anti-clockwise means opposite direction of clock. Okay, so that direction is called anti-clockwise direction. Okay, so the angle, say here theta, made by the line L with positive direction of x-axis and measured anti-clockwise is called inclination of the line. Okay, so inclination of the line is nothing but an angle that basically made by the line L with positive direction of the x-axis and measured anti-clockwise. Okay, remember this point, measured anti-clockwise direction. So see this figure. So here you can see the angle theta, okay, made by the line L with positive direction of the x-axis and measured anti-clockwise, means in this direction. Okay, so this angle theta is called the inclination of the line L. Okay, so theta is called here the inclination of the line L. So obviously, theta always lies between 0 degree and 180 degree. Okay, so here you can see this figure 9.2, and note this point, theta always lies between 0 degree and 180 degree. Okay, and then see lines parallel to x-axis. So the lines which is basically parallel to x-axis or coinciding with x-axis have inclination of 0. Okay, so if we have a line which is parallel to x-axis, or if the line coincide with x-axis, then we always obtain inclination of that line is 0 degree. The inclination of a vertical line. Okay, vertical line means that is parallel to the parallel or to or coinciding with y-axis. Okay, that is actually perpendicular to the x-axis. Okay, so the inclination of a vertical line is always 90 degree. Okay, so note this point. So now let us see definition. So if theta is the inclination of a line L, okay, then tan theta is called the slope or gradient of the line L. So what is slope or gradient of the line L? So if theta is the inclination of a line L, then tan theta, tangent of theta, is called slope or gradient of the line L. Clear? So the slope of a line whose inclination is 90 degree is not defined. Okay, as we know, tangent of 90 degree is undefined. Okay, so if the slope of a line whose inclination is 90 degree, then that case slope is not defined. Thus, m equal to tan theta, where theta not equal to 90 degree. Okay, so if we take theta is 90 degree, then that case tan 90 degree is not defined. Okay, so always we take m equal to tan theta, where theta not equal to 90 degree, where m is called slope and theta is called inclination of a line. The slope of x-axis is what? So what is the slope of x-axis? So the slope of the x-axis is 0. Why? Because the x-axis coincide with positive x-axis. Okay, and here the inclination is 0. Inclination is 0. Okay, so the slope of the x-axis, that is tan 0 degree, and tan 0 degree is always 0. So the slope of the x-axis is 0. And slope of the y-axis is what? The slope of y-axis is not defined. Why this is not defined? Because the y-axis is basically vertical line, okay, and the y-axis is perpendicular to x-axis. Okay, y-axis is perpendicular to x-axis. That means y-axis made angle with x-axis, that is 90 degree. Okay, and we have seen in before point, the slope of a line whose inclination is 90 degree is not defined. Okay, so slope of y-axis is not defined. Clear? I think it is clear to all of you. So now look at this figure 9.31 and figure 9.32. Okay, so here first of all, let P x1 comma y1 and Q x2 comma y2 be 2 points on non-vertical line L whose inclination is theta. So now basically we are going to discuss slope of a line when coordinates of any 2 points on the line are given. Okay, so if we have a we have a line and we have given 2 points on the line, then what is slope of that line? Okay, so first of all, we let here P x1 comma y1 and Q x2 comma y2 be 2 points on non-vertical line L whose inclination is theta. Okay, so obviously here x1 does not equal to x2. So x1 never equal to x2. So x1 not equal to x2. So otherwise the line will become perpendicular to the x-axis. Okay, and in that case slope will not be defined. Okay, so obviously x1 does not equal to x2. So take x1 not equal to x2. So the inclination of the line L may be acute or obtuse. Okay, so the inclination of the line L may be acute angle or obtuse angle. Okay, so what is acute angle? So if theta lies between 0 degree and 90 degree, then theta is called acute angle. Okay, so that means if we have an angle that is less than 90 degree, then that angle is called acute angle. So if theta lies between 90 degree and 180 degree, then the angle is called obtuse angle. Okay, so obtuse angle is more than 90 degree and less than 180. So now let us consider two cases. So first of all, we now draw a QR. Okay, QR, this line perpendicular to the x-axis. Okay, and PM perpendicular to the QR. Okay, QR as shown in figure 9.31 and figure 9.32. Okay. So let us take two cases here. So case 1, when angle theta is acute angle. That means when theta lies between 0 to 90 degree, that case what will happen? Okay, we will see. So when angle theta is acute, then we get this figure 9.31. Okay. So now draw perpendicular QR to x-axis and PM perpendicular to the QR line. Okay, that is shown in figure 9.31 here. So here in triangle MPQ, okay, see this triangle MPQ. So we have here angle MPQ is theta. Okay, so this angle is theta here. So therefore slope of the line L is what? So therefore the slope of the line L is M, and this is equal to tan theta. Okay, so naming this equation number 1. And but here triangle MPQ, here we have tan theta. This is equal to basically perpendicular divided by base here. Okay, so perpendicular is here MQ and base is MP. So tan theta is basically equal to MQ divided by MP. Okay, and here you can easily find the distance between MQ and MP. Okay, so you can find length of MQ and MP. So here MQ is basically y2 minus y1 and MP is basically x2 minus x1. Okay, and naming this equation number 2. So now from equations 1 and 2. So now we combine equation 1 and 2. Then we have M is equal to y2 minus y1 divided by x2 minus x1. Clear? So slope M is equal to y2 minus y1 divided by x2 minus x1. So now see case 2. Okay, so when angle theta is obtuse. So when angle theta is obtuse, that means when theta is greater than 90 degree, okay, and less than 180 degree. Okay, but that means theta lies between 90 degree to 180 degree. So that case, what will happen? We will see here. So see this figure. So now draw perpendicular QR to x-axis. Okay, we have drawn here perpendicular QR to x-axis and PM perpendicular to RQ, that is shown in figure 9.32. And in triangle MPQ, okay, in triangle MPQ, we have here angle MPQ is 180 degree minus theta. Okay, and therefore theta is what? So therefore theta is equal to 180 degree minus angle MPQ. Okay, so now slope of the line L is M equal to tan theta. So tan of 180 degree minus angle MPQ. Okay, and since we know tan of 180 degree minus theta is minus tan theta. Okay, so then we get tan of 180 degree minus angle MPQ. This is equal to minus tan angle MPQ. So this is equal to minus MQ by MP. Okay, and here MQ is y2 minus y1 and MP is x1 minus x2. Okay, so minus of y2 minus y1 divided by x1 minus x2. So therefore, m is equal to y2 minus y1 divided by x2 minus x1. So consequently, we see that in both the cases, the slope m of the line through the points x1 comma y1 and x2 comma y2 is given by m equal to y2 minus y1 divided by x2 minus x1, where x1 does not equal to x2. Okay, so if we take x1 is equal to x2, then that case the slope is not defined. Okay, so that's why we take here x1 not equal to x2. Okay, so both the cases we obtain the slope of the line m is equal to y2 minus y1 divided by x2 minus x1 when coordinates of any 2 points on the line are given. So that's one for today's session. So thank you very much to all of you.